Transformer oil or insulating oil is an oil that is stable at high temperatures and has excellent electrical insulating properties. It is used in oil-filled transformers, some types of high-voltage capacitors. The oil helps cool the transformer. Because it also provides part of the electrical insulation between internal live parts, transformer oil must remain stable at high temperatures for an extended period. To improve cooling of large power transformers, the oil-filled tank may have external radiators through which the oil circulates by natural convection functions. 1. Insulation. 2. Cooling. Properties. 1. Low density. 2. Low viscosity. 3. Low port point. 4. Low dielectric dissipation factor tan delta. 5. High flash point. 6. High chemical stability. 7. High electric strength PdV. 8. High volume resistivity. Should be non-toxic PCB-free synthetic fluid before 1990. Should be compatible consistent with transformer construction material. Should be chemically stable and retain property for longer time. Types of transformer oil. Generally there are two types of transformer oil used in transformers. 1. Paraffinic-based transformer oil. 2. Naphthenic-based transformer oil. The major differences between these two are molecular paraffinic contains long chains of hydrocarbon molecules while naphthenic contains rings of hydrocarbon, and paraffinic oil contains paraffin wax while naphthenic oil does not. The absence of wax allows naphthenic oil to remain more stable and have lower port points, remaining fluid in colder temperatures than paraffinic oil. Both oils are widely used in India as a base for many different applications. Naphtha oil is more easily oxidized than paraffin oil. But oxidation product, i.e. sludge in the naphtha oil, is more soluble than paraffin oil. Thus sludge with naphtha-based oil is not precipitated in bottom of the transformer. Hence it does not obstruct convection circulation of the oil, means it does not disturb the transformer cooling system. But in the case of paraffin oil, although oxidation rate is lower than that of naphtha oil, but the oxidation product or sludge is insoluble and precipitated at bottom of the tank and obstruct the transformer cooling system. Although paraffin-based oil has above-mentioned disadvantage, but still in our country it is generally used because of its easy availability. Another problem with paraffin-based oil is its high port point due to the wax content, but this does not affect its use due to warm climate condition of India. Properties of transformer oil. 1. Physical. 2. Chemical. 3. Electrical. 1. Physical. 1. Appearance. 2. Density. 3. Viscosity. 4. Flash point. 5. Port point. 6. Interfacial tension. 2. Chemical. 1. Neutralization value. 2. Oxidation stability. 3. Moisture content. 4. Presence of oxidation inhibitor. 5. Corrosive sulfur. 6. SK value. 3. Electrical. 1. Electric strength PdV. 2. Dielectric dissipation factor tan delta. 3. Specific resistance storage tank. Storage tanks are containers that hold base oil. An organization have many tanks of storage tank to hold different types of base oil. Blending tank. The mixing tank is a machine container that is used to blend base oil together. The tank is made up of stainless steel or mild steel with agitator facility. Size of the tank is depend on the organization. 30 kL is preferable because most of tanker in India having capacity of 12 kL to 30 kL. The tank is usually designed for mixing liquids that have different plumbing lines that are channeled from and to the unit. While the liquids are being mixed in the tank, they also get transferred to the next stage. Percolation. The term percolation is given to that method of filtering in which the oil to be decolorized, remove moisture and suspended matter is passed through a bed of granular adsorbent aided via the help of gravity. Also it improves the electrical properties due reduction of moisture and suspended matter. It consists of a vertical steel cylinder closed at both ends and provided with suitable man heads and pipe connections at the top and bottom to permit the introduction and discharge of clay and oil. A perforated plate or a wire screen at a slight distance above the bottom is provided, over which a heavy canvas blanket is placed and clamped to hold the clay in filter yet allow oil to pass through and out of the filter. Size of these filters varies considerably from capacities starting at 3 empty to several hundred. Vacuum filtration, dehydration and degasification of transformer oil. These processes of dehumidification of transformer oil and removal of gases is executed in the degassing chamber. The dissolved water oil separation or dissolved gas oil separation is possible at reduced pressure. Example: vacuum, due to difference of boiling point of water, gas and transformer oil. In the process of separation of gases, example carbon dioxide, carbon monoxide, methane, ethane, ethene, acetylene, etc. from the oil, it becomes important to retain the aromatic hydrocarbon so that the original properties of the oil are retained. Finished goods tank. Store the final product from finished goods tank. We load the tanker and drums. The tank is made up of stainless steel or mild steel with breather facility. If tank is made of mild steel, it should be coated. Tests: appearance, density, kinematic viscosity, interfacial tension, flash point, pour point, neutralization value, corrosive sulfur, breakdown voltage, dielectric dissipation factor, specific resistance, oxidation stability, aging characteristics, presence of oxidation inhibitor, water content, SK value, standards of transformer oil, national, 1. IS 335:1993, 2. IS 12463, 1988, international, 1. IEC 296, 1982, Class 1, 2. IEC 296, 1982, Class 2, 3. IEC 60296, 2012. Other, 1. BS 148, 1998 Class 1, Class 2. Grades of transformer oil: uninhibited, IS 335, 1993, IEC 296, 1982, Class 1, IEC 296, 1982, Class 2, IEC 60296, 2012, BS 148, 1998 Class 1, Class 2. Inhibited, IS 12463, IEC 296, 1982, Class I8, IEC 296, 1982, Class I8, IEC 60296, 2012, BS 148, 1998 Class I8, Class I8. Methanic, IS 335, 1993 Methanic grade IEC 60296, 2012 Methanic grade. Filling procedure. There are two main ways of transportation of transformer oil: by tanker or drums. During transportation, properties of oil should not change. It is possible to absorb moisture or oxidized by presence of air, so we need take care during filling. Tanker loading. Drums loading. Tanker. Tanker is the easy way to transport transformer oil. It is cheapest as compared to drums. Those company who have storage tank facility, they prefer tanker. Drums. Those company who does not have storage tank or want to use after long time, then drums quality remain good for long time. Process of filling. First, flush the tankers/drums with transformer oil. After fulfill the quality parameter, go ahead for filling. Before filling, nitrogen gas purge first. Nitrogen gas replace air from tankers/drums. Then start loading. Once loaded the tanker, take sample according to the procedure. Check the quality parameter. If OK, then we go ahead for dispatch. For drums, take sample according to the procedure during filling. If OK, then we go ahead for dispatch.